Hi guys, so today we're going to talk about three common, I don't want to say versions, but three common ways you might see the derivative in early calculus classes. You might even see the top one in like some early analysis textbooks too, probably. I have. So we're just going to go over what they mean real quick and kind of some intuition behind them. So for the top one, I think this is kind of the easiest to understand. That's just me though, because what you're really looking at well, obviously, limit as x goes to c of f of x minus f of c over x minus c. But if you take the limit away for a second, which is really the calculus portion of this, f of x minus f of c over x minus c is simply the rise over the run. It's the distance in height of a function between 2 points divided by the distance in width of a function, if you will, between 2 points x and c. And the only thing that makes this a derivative and special, by the way, without the limit, this is the slope of a secant line on a function. But with the limit, what makes it special is that those 2 points are getting, I really don't know what the proper mathematical term is, but they're getting very, very close to each other, infinitely close, so to speak. And in doing that, we get the derivative at the point C, as we take x, which is, any number on the real line, and it gets really, really close to C. We get the derivative of C. Or the derivative of the function evaluated at a point C. Okay, so the next one also has some pretty simple intuition behind it. What we're pretty much doing is taking a really, really, really small change in f of c, so f of c plus h. So a really, really small difference in the height, and subtracting that from f of c itself. So that difference, f of c plus h minus f of c as h goes to 0, again, is going to be infinitely small. And then we're dividing it by h as h goes to 0. But remember, h is just going to be the width, because our width is also getting infinitely smaller. We're kind of like converging to a point here. So in a way, this is kind of the same thing as the secant line we just talked about with the limit, but the only difference is it's being represented with h as opposed to the simple rise over the run. But to be completely honest, the top part, f of c plus h minus f of c, very much, in my opinion, kind of like mirrors the same idea as rise. And then the h itself, as h goes to 0, almost seems to be, at least to me, the same thing as x goes to c for the x minus c portion of the top one. So they seem kind of analogous, to be honest. And they are, because they give you the same exact thing. But it's just two different forms and two different intuitions. All right, and now the bottom one, this is the one that you'll probably see most often, and it's also the one that's the least, what's the word that a lot of mathematicians would use, a lot of math purists would use. They would say this is the least elementary version. They really like these other two versions because they're more like rigorous, I guess would be the word, whereas opposed to with this one, you're just taking the derivative operator and just kind of doing whatever you want. So pretty much, as long as f of x is a continuous function, something other, there's probably some other problem too. But as long as f of x satisfies a few conditions, then when you take the derivative of it, and then you plug in c for f prime of x, or you plug in c for the derivative of f of x for x equals c, then you get f prime of c all the same. Yeah, so that one's kind of the simplest, and it's the one you'd probably see the most often. But they all represent the same exact thing. They all represent the derivative at a point C. And I just think it's interesting to see these kind of different notations for the derivative, like wildly different, especially the top two, where we use kind of two different limiting methods. But again, I think it's so interesting because they're so analogous to each other. The x minus c and the h, again, kind of give off the same kind of idea. They're going to 0, or they're getting very, very close to 0. And in the top, as x approaches c for f of x minus f of c, you're getting infinitely close to 0. And the same thing's happening for the second equation, f of c plus h minus f of c. As h goes to 0, you're getting very, very close to 0. So I guess the whole point here is that the derivative is really weird, and there's some funky stuff going on here with limits that I don't really understand yet. But yeah, I kind of wanted to make this video for, anyone that might be interested in, just some differences in the derivative, and for myself, to be completely honest, as I continue to go forward. The derivative is a really interesting topic, along with its counterpart, the integral. And the limit itself is quite interesting. So yeah, in the future, or really, really soon actually, I'd like to make a video kind of in the same vein, but about integrals. I think the integral version of this with like Riemann sums is a little more disgusting and makes a little less sense, but I think it's still nice to look at. So yeah, that's it for this video, and yeah, I hope you enjoyed.